in this video I will do examples. I will do some examples on one sample confidence intervals. Example 1. Suppose you have a random sample from a normal distribution with mean equal to theta and variance equal to 1. Find okay. All right. Okay, so this is similar to case 1 that I considered in the previous video. Well, the first result is that if this is a random sample from this, the result that you should remember is the following. You should look at the video on, this is one of the properties I mentioned on the video on video on normal distribution. So this implies that x bar minus theta must be normal with 0 mean and variance 1 over n, and x bar minus theta divided by the standard deviation must have standard normal distribution. So in other words, root of n times must have standard normal. Okay. So using what I mentioned earlier on the previous video, this implies that the probability that this lies between these two, right, must be equal to 1 minus alpha, right? Okay, so that means that you should divide everything here by root of n. You get the probability that and finally make this into a statement on theta. This is what you get. This is the probability that x bar So the conclusion is the following, that hence the lower limit, comma the upper limit. So the lower limit is so that's example 1, it's an easy one. Example 2. Suppose so this is theta, sorry, it's theta, okay. Okay. So here you have a random sample from a normal distribution with zero mean and variance theta squared. Now, one of the results I mentioned in the video on chi-square distribution is the following. So, if you don't remember this, please see the video on chi-squared distribution. Okay. So this implies that 1 over theta squared times the sum of xi squared and this implies, from the video on percentiles, you will see that because this has the chi-square n, the probability that this lies between these two has to be equal to 1 minus alpha. Right? Okay, now we can convert this as a statement on theta squared, right? So you will get right. Now the question is to find a confidence interval for theta, not theta squared. So that means we need to take the square root. Now, because theta squared represents variance, theta represents standard deviation. And when you take this square root, you can have two roots, plus or minus. The minus root is invalid because standard deviation cannot be negative, right? So when you take the square root, you will only keep the positive root, not the negative root, because what I said, because the standard deviation by definition must be a positive number. So so the conclusion is that hence 100 times 1/1% for theta is the interval from this to this. So the lower limit is this is the lower limit, and the upper limit is this. Alright, so this completes example 2. Right, this is example 3. So here I'm going to suppose alright, this is a kind of question where it's really difficult to get a beginning for this kind of question unless you have a hint. So if I were to ask a question like this in the exam or one of the quizzes, I will probably give you a hint. So in this case, the hint I will give you is the following. Let z equal to the max of x1 to xn. Okay, and find the CDF of z and use it to find the confidence interval for A. So this is the hint I will give you if I were to ask a similar question in the exam or one of the tests. Right, so okay. So the first thing I want to do is to find the CDF of Z, right? So let's do that first. The CDF the probability that okay, So if the maximum is less than or equal to a fixed number, then each element within the maximum has to be less than or equal to that. Okay. Now, using independence, we have a random sample, which means IID. So using independence, you can write this as like this. By using independence. Now we know that this is the definition of the CDF. So this is simply f at z. This is also f at z. And you have n of them, so you have f of z raised to n. Okay, and so this will be z divided by a raised to power 2n. Alright, now we have derived the CDF. Now I'm going to show you how to use this as a basis for deriving the confidence interval for A. Right, to do that I'm going to show you, it will be helpful first to draw a picture of the CDF. So that's what I'm going to do here. So this is your z-axis and this is the CDF axis. Suppose this is 0, suppose this is A, this is 0, suppose this is 1. Right. Okay, and you should draw this as a function of z. I'm sure you know how to draw graphs. You must have done that in your calculus courses. The graph will look like this, right? Okay. Now we need to find 2 points along the horizontal axis, right? Suppose this one and this one, such that the area between these 2 points is the area between these 2 points. When I say that, I mean this area here. This area is 1 minus alpha. Right, so that means, right, if this area is 1 minus alpha, the remaining area must be alpha. So let's suppose that each of these area is alpha by 2. So suppose this area here, suppose this area is alpha by 2, and suppose this area 2 is also alpha by 2. Now the question is what are the coordinates of this point and this point? That's what we need to figure out, right? If we can figure out the coordinate of the x coordinate of this and the x coordinate of this, then that will help us to find a confidence interval. Alright, let me show you how to figure that out. So to figure out this coordinate, let's start with this one, okay? We need to set the CDF of z equal to alpha by 2. Remember, what you're looking for is the area to the left of this point, which is alpha by 2, right? So which implies that z divided by a to the power 2n is equal to alpha by 2, right? And this implies that z must be equal to a times this. So we have figured out the coordinate of this point, which to be equal to this. So let me put this in a box so that you can see. Oh, sorry, I haven't. So you can see from this box that the coordinate of this point is equal to this. Okay. Right. And similarly, to figure out the coordinate of this point, right, we need to put set the CDF, right, equal to the area to the left of this point, which is 1 minus alpha plus alpha by 2, which is 1 minus alpha by 2. So which implies that Z divided by A okay, so this implies that Z is equal to A times right, so this is the coordinate of this point. Let me put this in a box once again. So we have figured out the coordinates of the 2 points along the horizontal axis. This is the coordinate of this, and this is the coordinate of this. So the area between these 2 coordinates is 1 minus alpha, right? So let me write that down. So what I'm just saying is the probability that capital Z lies between this, which is this, right, and this, which is this, is equal to 1 minus alpha. Now, all we need to do now is to convert this statement into a statement on A, because the question was to find a confidence interval for A, right? So that's what I will do now. So this implies that the probability that Z divided by so as a statement on A, right? Now remember, Z is the maximum of xi, so let me put that. So the probability that the max of x1 to xn divided by equal to 1 minus alpha. Alright, so hence the conclusion, to conclude, so CI for A is confidence interval CI is the following. So the lower limit is this one, and the upper limit is this one. Okay. All right, so that completes example 3. The final example I will do is this one. Example 4. Now suppose right here Ln stands for log normal distribution. I hope you have seen that in probability 1. If not, you see that in the list of distributions in the course website. Right. One of the properties of log normal is the following: that if you don't know this, just you may know this. If a variable xi is log normally distributed with parameters theta and 1, then the log of xi will have the normal distribution with parameters theta and 1. So that's one. So the log normal and the normal are closely linked to each other. Right? So using this fact, using this property, you can see that the mean of the log of xi's, right, must have a normal distribution with mean theta and variance 1 over n. So that's one of the properties we talked about on the video on normal distribution. Right? So now if you subtract theta both sides, you get normal with 0 mean and variance 1 over n. Now if you standardize by dividing by the standard deviation, which is what I'm going to do now, so I'm going to divide by the square root of the variance, which is 1 over root of n. You will get the standard normal distribution, right? Now simplifying this, you get root of n in brackets Okay, now I'm going to use this as the basis for constructing a confidence interval for theta. Right? So this implies, using the symmetry of the standard normal, we can write the following statement. Now I'm going to make this into a statement on theta. Okay. So before I do that, let me do one step at a time. So for the first thing I'm going to do is I'm going to divide all the numbers here by root of n. So you will get and then convert this into a statement on theta. So we get the probability that this is what you get. Alright, so this statement gives the confidence interval for theta. So the conclusion is the following: hence 100 times is, so the lower limit is going to be this one. Okay. Alright, so this is the 100 times 1 minus alpha % confidence interval for theta. So this completes the video on examples on one sample confidence intervals, and in the next video I will talk about two sample confidence intervals.